Okay, elementary logic. Here we're gonna talk about the tautology. A tautology means a conditional statement. To be a tautology, the all possible outcomes should be true. Okay, I'll write here a conditional statement. To be a tautology, all possible outcomes should be true. That means if I take an example, if I take P O not P, I'm gonna draw the truth table. P not P, P O not P. Here, okay. Uh, when P is true, not P is false, then P or not P is true. When P is false, not P is true, then P or not P is true. So here we can see the all possible outcomes are true. So this is a tautology. Okay, let's take example. Example 1. P and Q implies P. Okay, here P, here Q, here P and Q. Then I can write here P and Q implies P. Okay, here when P is true, I write P column. True, false, false. Here true, false, true, false. Okay, then P or P, we gonna take P and Q. P and Q, here true, here false, false, false. Okay, then I gonna take P and Q implies P. Then from imply P and Q on, when we use the implies false when only true never goes to false. So here true, here false goes to true, that means true. Here false goes to false, that is also true. Here also false goes to false, that also true. So here the all possible outcomes are true. So this is a tautology. Here I gonna show you a easier method to solve this. First you can write like this way. Then P we can write true, true, false, false. Instead of Q we can write T, false, true, false. Okay, here P and Q means true, true, false means false, true, false means false, false, false means false. Okay, here we know the truth values are true, true, false, false. So this implies this part. Now we take this position to this position. So true goes to true, true. False goes to true, that is also true. False goes to false, that is also true. False goes to false, that is also true. So we consider this column as the first step. We write this part, and also we can write this also, then this one, then this is the third step, then this is the last step. Okay, from this we can write this is a tautology. Okay, let's take another example. Example 2. P O Q O and not P implies Q. Okay, I write P Q P O Q, then not P, then P O Q and not P, then P O Q and not P implies Q. Okay, Here P we can write true, true, false, false. Q I gonna write true, false, true, false. Then P O Q, P O Q. If one is true, then the outcome is true. So here also true, here also true, here true. This is false because both are false. Here not P, P is true, so not P is false. Here false, here false. This is true, this is also true. So now we're gonna take this one and not P, this one and not P to become true. Only both values should be true. So this only true. So these all are false. Here this goes to Q. So false goes to true, that is true. False goes to false, that is true. True goes to true, that is true. False goes to false, that is true. So here we can see this is a tautology. So I'm gonna write the easiest way to find this. P O Q and not P implies Q. Okay, if I write this one, P true, true, false, false. Q I can write true, false, true, false. So P O Q is true, true. Here true, here false. Okay, here not P we can write here when P is true, here the false, here the false, here the true, here true. So now we should consider this column and this column, that is true, false, and this is true only when both are true. So only this position it is true, so all the other positions are false. Now we consider this column and this Q we can write as true, false, true, false. So with this column, so here uh, false goes to true, that is true. False goes to false, that is true. True goes to true, that is also true. False goes to false, that is also true. So we can see this is all the values are true. So this also a tautology. Okay, here if I write these steps, we have to write this P and here Q as the second step. This Q also we can write. Then after solve this two, that is as the third step. Then write the not P, that is as the fourth step. Then take the end of this two, that is as the fifth step. And lastly this part, that is sixth step. Okay, a definition uh, in a biconditional statement, P if and only if Q happens to be a tautology, P is equivalent to Q and is denoted by like this way. That means in a biconditional statement, this is a biconditional statement. This to be a tautology, we should show this is true. This will happen. So as an example, if I take P O Q imply, but if and only if, not P and not Q. I gonna use the easier method to solve this. So P is true, false, false. Here Q I can write as true, false, false. So P O Q we can write true. Here also true. Here also true. Here false. Then here not P I can write as true, false, false. Here true, here true. Not Q I can write as false, false, true. So end of this two means if only this two is true, then only this value is true. So all the other parts are false. So if we take the negation of this part, this column, that is true, false. So here this column and this column are same. That means we short P equivalence Q. That means if this is P, if this is Q, we short P equivalence to Q. So I can tell this is a tautology.